Hey everyone, let's jump right into this. Today, we're doing a complete zoom-in, zoom-out journey through the actual anatomy of a computer system. We're going to totally unpack the evolution of computing and really decode those core concepts that make our entire digital world tick.
Here's our exact route for this explainer. 1. The evolution of computers. 2. The anatomy of information systems. 3. Speaking the machine's language. 4. Hardware, inside the box. 5. Software, or making it work. And finally, 6. Connectivity and the world.
All right, Section 1, the evolution of computers.
It's crazy to think about, but in just a few decades, computing has ripped through 5 distinct generations. We literally moved from massive, heat-generating machines powered by these super fragile glass vacuum tubes straight into the transistor age and then to integrated circuits. The 4th generation is what brought us microprocessors. The hardware that put the personal in personal computers, and that rapidly accelerated us right into the 5th generation, which is this hyper-connected age we're living in right now. The sheer physical leap in miniaturization here is, well, it's absolutely staggering. First-generation computers needed rows and rows of giant light bulb-sized vacuum tubes, but by the 3rd generation, an entire integrated circuit could literally fit through the eye of a sewing needle. It's just a brilliant visual of how computing power has exponentially shrunk in physical size while absolutely exploding in capability. Okay, moving right along to Section 2, Anatomy of Information Systems. When you look at a laptop, you probably just see a screen and a keyboard, right? But it's actually this complex living information system made up of 6 distinct parts. You got your procedures, the software, the hardware, raw data, and of course, the internet. But the absolute most critical piece of the puzzle? People, us. End users are literally the entire reason these systems exist in the first place.
Now, here's a super crucial distinction. Data and information are not the same thing. Data is just raw, chaotic, unprocessed facts. Think random text, numbers, or audio bytes. Information, on the other hand, is what you get after your software acts as a translator, processing all that raw data into something actually meaningful for human beings.
Let's put this into perspective. Imagine conducting a taste test asking 260 people for their favorite beer brand. A massive spreadsheet with 260 random text entries? That's our raw data, kinda useless on its own. But when the system processes that data, it spits out a clean visual bar chart. Boom! Now it's useful information and we can instantly see that brand C took the win with 60 votes. Section 3. Speaking the machine's language. Let's get into the code. So, we have a massive language barrier here. Humans speak in analog. When we talk, our voices create these continuous, rolling analog waves with all sorts of varying pitches and tones. But machines? No way. They only understand digital signals. We're talking discrete electronic on or off states. Because of this, a huge, instantaneous translation has to happen under the hood every single time you interact with a device. I absolutely love this quote because it grounds everything in a super simple truth. Electricity can either be on or off. That's the binary system in a nutshell. A 1 means an electric charge is present, it's on, and a 0 means no charge, so it's off. Every 1 or 0 is called a bit, and literally every single thing your computer does is just billions of these bits firing in sequence. Because binary is so ridiculously basic, computers rely on encoding standards to group those bits together and translate them into the text we read. Back in the day, personal computers used an 8-bit system called ASCII, and massive mainframes used one called EBCDIC. But today, our globally connected world absolutely demands Unicode. Unicode uses 16 or even 32 bits, meaning it can support thousands of complex characters for languages all over the planet.
All right, Section 4, hardware, inside the box. Hardware basically falls into 4 main buckets. You've got your supercomputers. These are those massive high-capacity beasts used for global weather modeling. Then there are mainframes, which process millions of records for huge organizations. Mid-range servers supply access to apps and databases. But for us, our daily lives are powered by personal computers. And yes, that includes your desktop, the smartphone in your pocket, and even that smartwatch on your wrist.
Looking at a typical PC setup, it's so easy to just stare at the monitor. But the real magic is happening inside the system unit. That's where the motherboard, the main circuit board, acts as the central communications medium for the whole setup. It links the brain of the computer, the CPU, to your volatile, temporary memory, like RAM, and to your permanent secondary storage, like a solid-state drive.
If we follow the data journey, it looks like this.
First, raw data is entered via an input device, like a keyboard or mouse. Second, that data shoots across data pathways, called buses, straight to the CPU. Inside the CPU, the arithmetic logic unit uses fundamental logic gates to crunch and compare those binary ones and zeros. Finally, that processed data is translated back and outputted to your monitor or printer as high-res information you can actually read.
Section 5. Software. Making it work. Now, hardware is basically just an expensive paperweight without instructions, right? That brings us to software, which actually splits into two completely different camps. Application software is for you, the end user. It's the word processors, the games, the apps you actually use to get work done. System software, though, that's strictly for the computer. It hums along quietly in the background, managing the hardware and handling all the technical details. And the absolute MVP of system software is your operating system. Whether it's embedded in your phone or standing alone as Windows or Mac OS, it is the boss coordinating all the resources. But system software also includes utilities like your antivirus, device drivers that teach your computer how to talk to a new printer, language translators, and the BIOS, which is stored in flash memory and literally wakes the hardware up when you hit the power button. And our final stop, Section 6, Connectivity in the World.
The ultimate piece of the information system puzzle is, of course, the Internet. Connecting these isolated systems fundamentally changes the game. When you send an email, transmission rules, or protocols like TCP/IP break your message down into tiny little packets and use unique numeric IP addresses to instantly route them across a massive worldwide web of servers.
But hey, remember that language barrier we talked about? Computers are digital, but a lot of legacy communication infrastructure, like old telephone lines, was built for continuous analog voice signals. So to send a digital 1 or 0 over an analog line, you need a modem. It stands for modulator-demodulator. It modulates the digital signal into analog for the trip and demodulates it back to digital upon arrival. It's just a really cool layer of real-time translation.
Now, the channels carrying all this data have wildly different bandwidths or capacities. A standard twisted pair Ethernet cable works great at home, but high-bandwidth fiber optic cables, they use actual pulses of light shooting through glass tubes to transmit mind-boggling amounts of data across oceans. And obviously nowadays, we're relying more and more on wireless channels like Wi-Fi and 5G cellular networks. So that brings us to the end of this explainer. We've traveled from giant room-sized vacuum tubes to microscopic chips all the way into our hyper-connected fifth-generation world. But considering researchers are actively testing brain-computer interfaces today, literally trying to merge human thought directly with digital processing, it leaves us with one incredibly provocative question. Are we on the verge of becoming half human, half machine? Where exactly is the sixth generation of computing going to take humanity? Thanks so much for hanging out and learning with me today.